So again, this is the video which express about the Phet simulation while teaching and running. We are going to see the different steps which are followed while teaching by using Phet simulation. By explaining, you remember that Phet simulation is the one which helps you to visualize even the concept in a very clear way to students, whereby they are running and by showing them how the different properties can vary, changing by the change of each other. Let us start and see how Phet simulation works. Then when you open this, you open the come on this bar, then we write uh, Phet, Phet simulations. Then when you come on this, then after opening this Phet simulation, it comes like this. Then I open the simulations. You have the simulations either in all domains like in physics, chemistry, math, science, and biology, and whatever. Then to this, for us, let us choose that you have Phet simulation in chemistry. Then the Phet in chemistry we have for us, me, I want to be on general chemistry, where we have the only two those Phet simulations. Let me talk about black body spectrum, to which we are going to talk about and see how the changes will vary. First of all, here we have to explain the student what are black bodies and how they vary with temperature. By explaining this, I think even we can come upon and then tell them to show how the black body radiations are. Those are the body radiations, which is thermal electromagnetic spectrum with the surrounding, where which changes will emit the temperature of the black bodies, which when we talk about the black bodies, we talk about opaque bodies, we all non-reflective bodies. Those are non-specific and for continuous, which vary with the spectrum, continuity of the spectrum, and the change of wavelength, which are inversely to the intensity that have been opened the body temperature. You understand that the body temperature will make the value of that black body by changing it with the temperature change. Means the radiation in the radiation spectrum will change as the temperature radiation changes. For this, we are going to see the Phet simulation as we are interpreting our formula. You see that here we are having this is the speed of power density, which changes with the wavelength. Then you remember that here 1 nanometer is equal to 1000 nanometer, whereby they have been on this square while showing the change. Let us, in order to be very clear, understand those are the primary colors, the red, blue, green, and blue, which changes as the radiation and wavelength change. So here we have the thermometer. This thermometer is the one which will show how the simulation changes with the body radiation changes as we increase temperature or we reduces. Well, you remember, you see that this one is graduated in Celsius, and this is the sun, and this is the right bulb, this is the earth. Those are the different levels whereby the different radiation or the temperature are emitted. This is the earth area, this is the right bulb when called like torches, like the other writers. This is the sunshine, and when with the temperature which are expressed in Celsius or in Kelvin as the black body temperatures. Let us name our graph so that when we change, we vary one variable, another one will vary according to the variation of another one. Let's vary the intensity. Shall show how the intensity will change. You see, that when I do like this, you understand that this is how the intensity will change. It means the variation, you see the highlighted peak will change as we are going to change it. This means that is 6.42 times 10.7 watt over meter square. We label it. Then you see that's the extreme to maximum, which is ultraviolet, the visible light, that is the infrared on this region. Then you see about the graphic value. Then you see we are at you see the wavelength we are having here is 0.5 and the spectral density is 84.46. Now, as we are using Phet simulation, we are going to see how it changes as we are changing the one of the variables, how one variable will affect another one. Suppose we are increasing the wavelength. If the wavelength increases, you see that the intensity also increases, the spectral power density increases. You understand? You see, it is increasing. As you remember that you have been given that 1 micrometer is equal to 1000 micrometer. That is why you see it is changing on that level. Let us come back on the initial state like that one. You see it is changing as we change the wavelength, increasing the intensity go on that side. Then when we decrease, it goes to the side of the visible light. Then when we change also the spectra, like when we increase also the intensity. Then you see when we decrease, it comes down as the temperature also decreases. Understand that that's how the Phet simulation can explain that concept of black bodies. So you see how when the temperature decreases, you understand, you see that this area is also decreasing as we are decreasing temperature. Means that when the temperature decreases, means this is the power on this axis, then means when it increases, understand, you see how the black bodies will change according to the change in temperature. When we increase the wavelength, we even change the region from the visible then as done, you see that it changes from one side to another as the one given is in infrared, in visible region, as we have the primary colors, the blue, green, and the red. This is how Phet simulation is used. Thank you very much. This is one of the examples I have given about explanation of black body.